On the behalf of Power Engineering of Technology, Automobile Engineering Department, I heartily welcome Catalytic Converter Rajkumar Bagel for today's talk. First of all, Rajkumar Bagel has a vast experience of 40 years in a force. During that tenure, he has served as a many positions like a head faculty and senior technical instructor and course supervisor at Tetra School Air Force Station, Vadodara. He is also served as a member of Tactical Instruction Team of Air Rescue at Vayu Bhavan, New Delhi, and he has given many lectures as a guest faculty in a various engineering college. He also is very willing to guide various at the various levels of automobile engineering students for their project. So I would like to now hand over this talk to the Rajkumar Bagal sir for today's talk. Over to you, sir.
Thank you. Thanks a lot, uh, HOD Mechanical, Automobile, and Professor Jogal sir for inviting me to deliver a talk on my favorite subject, that is combustion of SI and CI engine and emission and its control. Good afternoon to everyone who are joined. At the outset, I would like to wish everyone a very healthy, colorful Deepavali with good health as we are emerging from the epidemic COVID-19. My today's talk will be on combustion of SI and CI engine, emission and its control. We would like to know the combustion process in engine also to understand the better how to control the combustion and then how to control the emission pollution. As we know that engine is a device which converts our fuel energy or chemical energy into a mechanical energy. We have a SI engine, that is spark ignited engines, where the gasoline is used, petrol or gasoline is used. We have a CI engine, compression engine, where the diesel fuel is used. Our aim as a industry, as an automobile engineer, is to make a efficient engine. So to make a efficient engine, we have to increase the various engine parameters efficiencies. For example, mechanical efficiency, volumetric efficiency, indicated thermal efficiency, and the brake thermal efficiency. These efficiency, our target, our aim generally is to increase the efficiency. We, of course, we increase this efficiency, but when we increase this efficiency, what is the side effect on the environment, on the human health? We are less bothered. So we will we will see how this problem is encountered, rather controlled. As we see, the most of the automobile manufacturers worry about the SFC, that is specific fuel consumption. As we are seeing with this graph, a normal conventional type multi-point injection vehicle and the direct injection vehicles, there is a reduction of 40% fuel consumption. A direct injection vehicles will have 40% less fuel consumption than the conventional type vehicle, which we were having at the olden time. Next parameter is every one individual customer as well as the automobile sector is worried about downsizing the engine. How we can make our engine small, but at the same time to deliver maximum power. So the thrust is on downsizing of engine that we can do by forced aspiration and direct injection. Here we can compare the three types of combustion processes which are presently in the industry, or as per present scenario we have a three type of combustion process in our automobile engines. The first is in the SI engine we have a spark plug. The second, we have in the diesel engine CI combustion we have a fuel injectors, and the third is HCCI homogeneous control combustion engines. We have a fuel and air mixture supplied into the combustion chamber and it is being burned. Here the fuel is injected inside the combustion chamber. Here the air and fuel mixture is delivered in the combustion chamber and the spark plug is ignited. Awesome. Screen is not visible. Okay, okay, दोबारा करता हूँ. Is it visible screen?
Yes, sir. Yes, sir.
Okay, okay. So we were discussing about the three types of combustion process: SI combustion, CI combustion, and HCCI combustion. The difference between the three is that the first one, the spark plug, is used to ignite the air and fuel mixture. In the second one, the diesel is injected at the end of the compression stroke, and in the third one, the air and fuel mixture is down into the combustion chamber and it is auto ignited due to the compression and increased temperature. So these are the three processes presently we have in our engines. Then comes the method of fuel supply. How the fuel is supplied to the engine. In the conventional type, where we have a carburetor, there the carburetor is a device which supplies air and fuel mixture. The mixing takes place before the combustion chamber in the induction manifold, or rather we can say in the carburetor. In the port injection, the fuel is injected in the induction manifold, or rather we can say in the intake port. There can be a multi-point fuel injection at the intake port. In the direct injection, the fuel is injected directly into the combustion chamber. Then we have one more advanced combustion process that is called stratified charge combustion, where the fuel is sprayed near to the spark plug because the fuel has to burn. So if the fuel is sprayed at the center, till the time the fuel reaches to the walls of the cylinder, the mixture gets cooled down, so the complete burning will not take place. In case of stratified charge combustion, the fuel is sprayed at a point near to the plug, so more combustion will take place. The third is turbocharged direct injection, where all the BS6 vehicles, now it is a mandatory that as per the we are running in the phase of BS6, that is Bharat stage 6 standards. So as per this, all vehicles should have turbocharged direct injection to reduce pollution, and rather of course we have a maximum output, or we can run our engine with the linear mixture. And as we know, the linear mixture will give less pollution. This is direct injection with auto emission, as we have discussed in HCCI engine. The direct injection takes place inside the combustion chamber, and maximum ultra lean mixtures can be obtained by direct injection in the combustion chamber. The other benefit is, as per the load or high, less load, more load, the quantity of fuel is injected at early or at later stage, which depends upon the requirements. Next, we can also maximize the combustion by shaping, by improving the swirling action of the mixture, by shaping, by designing the combustion chamber, or rather we can design a combustion chamber, we can design a shape of a piston head also accordingly, so the swirling, the mixing of air and fuel mixture takes place more. This already we have discussed. Now there are limitations of HCCI engines, because if the mixture is lean, then sometimes the incomplete combustion may result, which will lower our power, and high hydrocarbon and carbon monoxide emission will take place. So in HCCI engine, the air and fuel ratio plays an important role. Normally, the 14.7:1, that is 14.7 parts of air and 1 part of fuel, is the correct ratio which will deliver the maximum power, and it will give a good specific fuel consumption. If the mixture is rich, then the knocking will occur, and that knocking will damage. Knocking is nothing but sudden ignition of our combustible mixture, and which generates a high power, rather a knock, a sudden explosion on the head of the piston head. So it can damage the cylinder valves as well as the piston heads. At the same time, it will give more nitrous oxide emissions. We can, at a glance, we can compare a direct injections and the port injections. Here the injections is taking place before the combustion chamber. Here the injection of diesel is taking place inside the combustion chamber. This is the behavior of direct fuel spray, where we can see if the fuel is directly sprayed into the combustion chamber and what time it's sprayed. If it is sprayed at 40 degree before TDC, this will be the spray formation 30 degree before and 20 degree before TDC centers, the complete mixing will take place. So, in case we are able to control the time of the fuel spray, we will be able to control our combustion process. So this is the most important thing. In the subsequent, we will see that the mechanism, the devices are there in the latest automobile engine where we can control the time of fuel spray. This is a diagram of gasoline direct injection with turbocharger. As I said, the turbocharger is must, which reduces our pollutions. So here the turbocharger is run by the exhaust gases. This is exhaust gases. This is a turbocharger. One end the turbine is mounted, the other end the compressor is mounted. So the compressor will suck the fresh air, it will get cooled, the compressed air will go to the manifold and finally to the combustion chamber with a pressure. So optimum charging of cylinder will take place. Now there are various sensors because this lambda sensor which senses quantity of oxygen in the exhaust, which will control the air and fuel mixture ratio. We will see later on. Now there is a limitation of TDI, that is direct injection. Turbocharged direct injection, there is a limitation. That is, setup is very expensive because the turbocharger is very costly and the speed of turbocharger is very high. The maintenance also required, extensive maintenance is required on this turbocharger. The performance of the engine at initial stage when we start fitted with the turbocharged engine, at initial stage it gives poor performance, rather it gives less output because the temperature of the exhaust gases are lower. The cleaning process is also not fully efficient, means incomplete cleaning process because some of the exhaust gases not leaving the combustion chamber. Then one of the phenomena is auto ignition, means as we have discussed, the combustion mixture is ignited automatically. So this is a means to control. It is to be controlled, otherwise it will harm the engine. How we can control? We can control by increasing the surface area of the combustion chamber, by decreasing the flow rate of the mixture and other systems. Now comes to the most important things, that is emission control. As we are running in a scenario where we are going to face this problem, as we are facing the COVID-19 problem we have faced. If we connect our COVID-19 with the pollution, I think very well we can connect it, because as the pollution, the effects of pollution on health, as we will see in the subsequent slides, definitely we will come into the conclusion that if we are able to control pollution, definitely we are able to control various type of epidemic as COVID-19 or other disease.
Delhi government on Wednesday tested the anti-smog gun, a machine that sprays atomized water into the atmosphere to control air pollution in unheated areas. The device is connected to a water tank and mounted on a vehicle and can be taken across the city to spray water to settle the dust and other suspended particles present in the air. The company which manufactured the anti-smog gun said that the machine can spray water up to a height of 15 meters and the result is positive as the spray acts like clean and settles dust particles and also PM2.5. The trial run is being carried out by the Environment Department and demonstrates the safe usage in presence of Environment Minister Imran Hussain.
So we have seen that we are not fighting a war. If the screen is visible, Mughal sir?
Yes, sir. Yes, sir. Yes, sir. Visible.
Okay, okay, okay. So as we have seen that we are fighting one more war with the pollution. Apart from the conventional war which we were fighting with the Pakistan, with the China, so in the next future, it is not strange that if we have to fight a war with the anti-smoke gun with the pollution. As I have shown you, it is a scenario in Delhi that Delhi in the winter it is very difficult to breathe. In Chandigarh, as we have seen in the recent uh, news, that the Chandigarh is also a most polluted city where the government is installing the pollution free towers which will purify the air, rather the purifier tower, the air purifier tower, the need of air purifier tower in Chandigarh, the government has installed to purify the air. So the time is not far away. We may have to fight a war with the pollution. Now, to control the pollution, we will focus. Of course, there are various types of pollution in the atmosphere: industry pollution, thermal plant pollution, sound pollution. But here we will focus only with our automobile pollution. Why emission control? Everyone wants to be comfortable. Everyone wants to use vehicles. But what is the side effect? What is the ill effect? No one cares. The main pollutant which is emitted by the automobiles are carbon monoxide, hydrocarbon, nitrogen oxides, sulfur dioxide, particulate matter. It is a fine particle of carbon and aldehyde or some lead compounds. These are the harmful chemical compounds which adversely affects our health, and it is emitted by our engine. Total 30% of GDP is goes on the health. Now it might have increased. It is earlier data. Why? Because as we have seen in case of corona, how much the health infrastructure has cost to the GDP. The most disease, the respiratory disease, which is as per my view, we can link into with the pollutants, because the pollutants decreases our immune system. The pollutants affects our respiratory systems, and of course the corona also affects our respiratory system. So our respiratory system has gone weak due to the pollutants, and then the corona has taken its toll. Maximum chemical compound which is emitted by our exhaust gases affects the respiratory system. Of course, the carbon monoxide affects the blood delivery. These are the effects on the people. Not only human, but plants are also affected. The yields of the plants are day by day, they are giving less yield. The soil infertility is also going, it is increasing. Now the technical question, what are the sources of pollution? From where the pollution takes place from our automobile vehicles? The automobile vehicles, the pollution takes place from the crankcase, from the fuel tanks, from the fuel system, and lastly the exhaust system. These are the key points from where the emissions of the hydrocarbons takes place. From the carburetor, from the crankcase, tailpipe, this is exhaust system, and the fuel tank. These are the four key points from where the emission of hydrocarbon takes place. If we are able to limit, rather reduce the emission from these 4 points, we will be able to control our pollution from the automobile. So our first area should be how to control the pollution from the carburetor, from the crankcase, from the tailpipe, and the fuel tank. If we are going to design our engineering to control the pollutants, we can design it in 4 steps. Number 1 is our thrust area, the main aim should be a complete combustion inside our engine. The air and fuel mixture or the fuel mixture should completely burn rather inside the combustion chamber. If it is completely burned, then we have a less pollution through that gas. So we have already seen GDI, TDI, FCCI type of engine. The next is how to control the mixture which has been burnt and it is going to atmosphere. Still, there is some pollutants in that. So again, if we are recirculating it, again we are checking. Again, if we are checking the exhaust system, we can control the pollution. This is the second step engineering. The third step engineering is we have to devise certain devices, so that whatever pollutants left behind after the second stage, again we are arresting them. We are checking them. That we can check by devising various devices such as catalytic converter, etc. And the fourth one, that is not the least, the eco driving. We cannot make our vehicles 100% pollution free, but still eco driving means driving practice. How to drive our vehicles? If we are driving carelessly, we are driving we are running our engine at the red light points. We are not switching off our engine at the red lights. We are driving hurriedly, at maximum speed, sudden braking, sudden starting. These are the major points which contributes to the pollution. So by eco driving, by smart driving, we can minimize our automobile pollution. We can also, at the first step, we see what are the things we can do in the first step engineering. We can control the combustion process. We can reduce the combustion chamber area. We can lower CR or compression ratio. We can vary it. We can do certain modification on the fuel. Stratified charge, already we have discussed. Variable displacement means when we require or when we don't require, that time we can cut off or cut on some of the cylinders which are firing in our vehicle. By that we can control our pollution. So this is the first step of engineering. The list of engineering in the first step is variable valve timing. Why varying the valve timing? What time the valve should open, how much time the valve should remain open. That is called VTAC technology, variable valve timing. By that, by using, we can limit our pollution. So there are three types of technology we have in recent engine, that is VTAC technology, VTC technology. VTAC technology means where the only the lift, the time, the duration of valve lift is controlled. And VTC technology, what time the valve should open, what time the inlet valve should open, or what is the valve overlapping. Valve overlapping means the intake valve is open and the exhaust valve is not closing. Means both the valve, intake as well as exhaust valve is open. How much duration it is open? If it is controlled, we are able to control the pollution. So this technology is called VTC technology. And third one is the mixture of both the technology, VTAC, VTC. We call it intelligent VTAC technology, where we use both the technology. Now, one of the most important, or the earlier also, the positive crankcase ventilation, where we arrest our harmful fumes with gas condensed in the combustion through the combustion chamber in the crankcase. The next is fuel tank evaporation. Whatever vapor is present in the fuel tanks or the vapor present in the carburetor, how to arrest them? So by that we can control the pollution. How to heat the combustible mixture by heated air system. How to treat, rather control the exhaust gases. That is by EGR, exhaust gas recirculation. Again the exhaust gas are recirculated to the combustion chamber. Or by fitting the catalytic converter. So these are the some methods we can use for controlling the pollutants. This is the positive crankcase emission controls. As the engine breathes, as the human breathes, the engine also breathes. The fresh air is drawn through the combustion chamber, and this is the crankcase where the harmful fumes are generated. The fumes are to be expelled outside. Otherwise, the fumes are not expelled outside from the engine crankcase, the crankcase pressure may rise, it will get burst. So these are to be sent out, but if it is sent out without check, there will be a pollution because it contains very dangerous hydrocarbon particles. So it is to be controlled by positive crankcase ventilation valves. This is the location where the positive crankcase valve is located. It is located between the crankcase and the inlet manifold. It will work as per the vacuum of the inlet manifold. Now this is going to the intake manifold. This is the valve. Now the mixture, rather hydrocarbon from the crankcase will come through this PCV and it will go to the intake manifold. Again, that mixture, the hydrocarbon mixture which is expelled out from the crankcase will burn inside the combustion chamber. Now we can say it is a recirculation process of the hydrocarbons emitted from the crankcase. So this is the position when the speed is low. When the speed is low, the valve is closed under the tension of the spring. It is not fully closed. It is closed. Why? Because the vacuum is high. As we have seen here, this is a passage which is connected to the inlet manifold. When at starting the throttle valve is closed, most of the vacuum is felt here to the PCV valve. Maximum vacuum is there. So when the maximum vacuum is there, the valve is pulled toward the right. So from crankcase, less mixture will be going to the induction manifold. When the speed is more, the vacuum to the PCV valve is less. So the valve goes to the left. So more passage is open. So maximum gases coming out from the crankcase goes to the induction manifold for reburning. So this is how PC valve operates as per the load and throttle opening conditions. Now fuel vapor control system is whatever fuel vapor is there. Definitely there is a fuel vapor in the tank, in the carburetor. If the fuel vapor, which also contains hydrocarbon, goes into the atmosphere, it will pollute the first. Secondly, if the fuel vapor goes to the atmosphere, the fuel consumption will be more because the fuel is getting evaporated and it is going to the atmosphere. So the load on the pocket will be more. So if we are able to recover that fuel vapor, we are benefiting by twofold. Number one, reducing the pollutants. Second, reducing the cost of it. So in most of the vehicles, these charcoal canisters, this device is fitted which will collect vapors of the fuel tank or vapor from the carburetor. There are pipelines. So here the condensation will take place and the filter is installed. This is connected to the manifold, intake manifold, and when the engine is started, as per the vacuum, the fumes again goes to the induction manifold. This is a heated air system where the air cleaner, the heating device is installed, so the air is heated. When the air is heated, the combustion mixture is heated or it will burn completely. For the cold starting device, it is very important when we are starting our engine in cold. We also call it thermostatic air cleaner. Now lastly is exhaust control methods. We have devices various engines with the various mechanisms to control the pollutants, but still if the exhaust gases are coming out, now our aim is to clean the exhaust as far as possible. So we have devices, various exhaust control methods as by EGR. One of that exhaust gas desalucation, catalytic converter, after fitting afterburner in exhaust manifold means again we are treating the exhaust gases by these three methods, that is EGR, catalytic converter, and afterburner. Now, EGR exhaust gas recirculation system, it works when there is a light load or when there is a more load. So the valve is installed, that is called your EGR valve. This is a EGR valve which will work under the pressure of exhaust gases. This is EGR valve, and it is also connected through a pipe to your throttle valve, below the throttle valve, rather valve. As per throttle valve, this EGR valve will operate. It will operate as per the vacuum, as per the engine requirement. When the throttle valve is closed, the full vacuum will be there. But if the vacuum is here, the diaphragm will be lifted up and the exhaust gas will go to the intake manifold. Rather, the exhaust gas will recirculate inside the intake manifold. It will go to the this combustion chamber. So this is controlled again by the engine requirement, that is by the vacuum. It is as it is working in the same phenomena as of PCV, positive crankcase ventilation. We can inject extra air into the induction into the exhaust manifold. As we know, there are exhaust sensors, or rather we can say oxygen sensors are installed in the exhaust manifold, which will sense your quantity of oxygen present in the exhaust. If the oxygen is less in the exhaust, means your mixture is rich. So our device, electronic control unit, will alter that mixture. If the oxygen is present more in the exhaust, means your mixture is lean. So the lean mixture as well as the rich mixture both are creating more pollution. So this is controlled by injecting extra air in the exhaust manifold. How the extra air is injected, how it is controlled, it will be controlled by the oxygen sensor which is installed in the exhaust manifold. And rather, it is electronically controlled. Now most of the vehicles have this oxygen sensor electronically controlled. This is a air spirator valve which gives extra air into the exhaust manifold. It works under the vacuum created by the exhaust manifold. When the more vacuum is there, the valve is open, more air will go. This air is coming from the air cleaner. So the more air is going to the exhaust manifold, so whatever unburnt hydrocarbon is there, that is getting burned in the exhaust manifold, and then it is going to the atmosphere. Now comes the important, that is catalytic converter. Now we have devices which converts our hydrocarbon, carbon monoxide, nitrous oxide into a less harmful chemical compounds. So we have a catalytic converter. We have a two-way catalytic converter. We have a three-way catalytic converter. The difference between the two is that the two-way catalytic converter only caters for the hydrocarbon and carbon monoxide, and three-way catalytic converter acts on nitrous oxide, hydrocarbon, and carbon monoxide. All the three, if chemical compound is react, and then these chemical compounds converted into the less or no harmful compounds. The compound which is very costly, that is platinum, palladium, and rhodium. Platinum, palladium, and rhodium, they are coated on the metal surfaces to convert hydrocarbon into the less polluted hydrocarbon. For example, the two-way converter have a platinum and palladium, which is an oxidizing agent. Oxidizing means the oxygen is added here. The carbon monoxide is very dangerous. So if the oxygen is added here, it converts into a carbon dioxide, which is less harmful than the carbon monoxide. In the same way, the hydrocarbon is converted into the carbon dioxide and the water. So this is called oxidizing agent. The platinum and platinum coating is there in the two-way converter, which is converting carbon monoxide to the carbon dioxide, hydrocarbon to water and carbon dioxide. In case of three-way converter, the rhodium coating is also there in one of the compartment. In the two compartment is there. In the three-way converter, three compartments are there. In the third compartment, rhodium, which caters to convert the nitrous oxide into the nitrogen and oxygen. Of course, the nitrogen is not harmful. So we can see here, it is a three-way converter, three chambers are there. This is a inlet from where we can feed extra air to burn the unburnt hydrocarbon in the converter. Now it has a limitation. If the fuel ratio is not maintained properly, the costly metal coating, rhodium, platinum, if the ideal fuel ratio is not maintained, the coating will get spoiled. It will get burned. The second is, we must use unleaded petrol, which sulfur content should be less. Unleaded petrol should be used. Otherwise, if we are using the leaded petrol, lead is there, it will stick on the surface of the platinum and rhodium. So the catalytic converter will become unserviceable. Now latest induction is there, that is to arrest the particulate filter. Most of the diesel vehicle, the PM, particulate matter, are large that are emitted by the diesel engines. So That filter is there in the most of the diesel vehicle, which arrests your particulate matter. This is the structure. Now comes to the emission standards. We are running at the stage of BS6. That BS6 stage started in 2019. Of course, we are more efficient to implement this BS6 standard at the correct time at the national level. We have implemented it before time, even before 2020. It is started in 2019 in NCR. We are quite ahead. We have implemented it successfully. Presently, we are running in the stage BS6. Our vehicles are qualified as per the BS6 stage. The difference between the two stage BS4 to 6, we have bypassed 5 because the problem of pollution is so much, we have to bypass the BS5 stage. So directly we have jumped from BS4 stage to BS6 stage standard. The difference is only the 3 components, that is hydrocarbon, nitrous oxide and particulate matter. So in the previous, this was the limitation, and now this has to be limitation. So presently our vehicle, our manufacturers, they are designing their vehicles as per the BS6 standards. The particulate matter should be 0.0045 gram per kilometer. The vehicle should emit this much quantity of pollution per kilometer. So this is the standard. The thrust area in the BS6 is the sulfur content should be very much less. Ultra sulfur fuel. Earlier, of course, there was a pressure on the refinery to supply the ultra sulfur fuel to all the petrol pumps at the initial stage, but they have managed. Presently, the ultra sulfur fuel is available on all the petrol pumps. Now, what are the future roadmaps and challenges? As we are knowing, our energy sources are deflating. As we know, the coal, in the past we have heard the news, the crisis of coal. We had to shut down various power plants. We have to search for alternative fuels, that is hydrogen gas or other fuels, because until the cost of the petrol, as we are aware, day by day is increasing, growth. Implement electric technology. Of course, electric vehicles are in the market. Sale of electric vehicles are increasing. To encourage sale. They are also if you have electric vehicles, you have to build stations, electric batteries, which can have it last long. And some research is in order to do. One of the challenges now that the catalytic converter is very costly. because the metal which we have discussed, rhodium are very costly. So there are some material it can be used as material of a converter. In lieu of rhodium. Now there are government steps. The government has taken various steps the system. They recently have policy our road transport ministry and announced that policy you can check how much pollution they are generating. One more, the system is varying for all the vehicles which is being manufactured in the India. As per the taken steps to increase sale of the electric vehicles, as we are aware, the registration charge is not there, the toll tax is also not there, the parking tax is also not there, and these vehicles, electric vehicles, are issued with the green number plates. To discourage the use of old vehicles that are older than 15 years, 9 years, the government has added one more tax apart from the road tax, the registration fees, one more tax they have added, that is called green tax. If we are going to run our vehicle which is older than 15 years, we have to pay 10 to 20% of more road tax on that vehicle. So the government is taking steps to discourage the use of old vehicles because the old vehicles generate more pollution. There are some key points of the scrap policy which is in effect with effect from the March 21. Some incentives of scrap policy. If you sell out a old vehicle and you obtain a scrap certificate, then if you purchase a new vehicle in lieu of old vehicle, you have to pay 15 to 25% less road tax. Means 15% less on the on the private vehicle, 25% less on the commercial vehicle. Road tax, less road tax. And the auto industry, from where you are purchasing a new vehicle, will also give you 5% rebate on the selling price. Of course, there will be no registration fees. To increase the sale of the old vehicles, 4 to 6% more incentive will be given on the sale of old vehicles. To discourage the use of old vehicles, the government has implemented a rule that the fitness certificate which we obtain after the 15 years or 9 years, whatever the case, if we obtain the fitness certificate, we have to pay more fitness fees. We have to pay fitness fees to obtain a fitness certificate after expiry of 15 years of life of a vehicle, we have to pay more. And the frequency of fitness certificate. Suppose we have to produce a fitness certificate after every year. The government has devised a rule that we have to produce a fitness certificate twice in a year. After every 6 months, we have to produce a fitness certificate. That is only to discourage the use of old vehicles, which is older than the 15 years. With this, I have finished my topics. If anyone have a question, you are most welcome to ask.
Thank you very much sir, for your this wonderful topic. One question is from student side. Can you give some comparative points regarding HPCI engine and turbocharged engine?
Question is not clear.
Can you give some comparison for a HPCI and turbocharged engine and its application?
HCCI engine.
Comparison of HPCI and turbocharged engine and its application.
Okay. So, is it screen is visual?
Yes, sir.
Now this turbocharger engine, the main motto to devise the turbocharger engine is to drive a maximum output, maximum power with the compact engine. The phenomena, the idea behind is that we want to charge our combustion chamber with the maximum combustible mixture to get more output. If a mixture drawn inside the quantity of mixture drawn inside the combustion chamber is more, you will get more output. So here we have seen here, this is a turbocharger which runs by the exhaust gases. On the turbocharger, we have two devices. At the one end, the turbine is mounted. At the other end, the compressor is mounted. Compressor is mounted means this will suck the fresh air, clean fresh air from the air cleaner. The compressor will compress the air through this intercooler if it is required cooling, because the air gets more hot. If it requires cooling, after cooling, it will go to the induction manifold. Your induction manifold is charged with the compressed air, means the air is under compression. As soon as the inlet valve opens here, the compressed air will rush in. Now, this turbine, when the engine runs, the exhaust valve opens, the exhaust gas is coming out through this. So the exhaust valve will push this turbine, and the turbine will use the energy from the exhaust gases. Rather, the turbocharger will run with the help of exhaust gases. We don't require any extra source to run this turbocharger. So turbocharger increase the efficiency of our engine. So most of the engines, they are fitted with the turbocharger. Is the turbocharger, how it gives more output is clear?
Yes, sir.
Okay, now we are coming to the SCCI engine. SCCI engines, the main idea is same. The first one is to have a less pollution. The second one is to have a maximum output. Now, how the maximum output can take place in case of SCCI engine? The mixture, homogeneous compressed mixture, means the engine is devised such that the mixture is prepared before it goes into the combustion chamber. It is prepared before the combustion chamber. Rather, we can say it is prepared inside the induction manifold, where the air is drawn. The compressed air may be drawn from the turbocharger. The compressed air is available, or the fuel is also injected as per the requirement. So there, the mixture is prepared inside the induction manifold. Now that mixture is going to the combustion chamber. If the quantity of that mixture can be controlled as per the various speed of the engines, we can control the output of engine. So the efficient firing will take place. Now this is a SCCI engine is that we can say there is no sparking plug. The firing will take place automatically. The burning will take place automatically. Now here we can change the as per the latest vehicles, latest devices, we can change the compression ratio as per the engine speeds. So if we are changing the compression ratio, we are able to control the process. In case of SCCI engine, we are able to completely control the burning process of fuel and air mixture. If we are able to control the burning process of fuel and air mixture, we are able to control pollution and we are delivering maximum output from this type of engine. So this is the basic difference.
Okay, sir. Thank you very much. Thank you very much.
Thank you. Thank you.
Okay, sir. So finally, on the PR4, Parvati University and Mechanical and Automotive Engineering Department, I will ask you five guided lecturers Kumar Bagal sir to deliver very interesting topics and give a very good areas to research upon on the engines and emission controls. So thank you very much, sir. Good day.
Thank you. Thank you very much. Thank you. Have a nice day. Thank you.
Thank you, sir.
Thank you.